Hello, everyone, and welcome to today's Tech Talk, an intro to computer vision for businesses. I'm your host, Ben Kotvis, Chief Architect of IoT, and joining me today are my colleagues, Amol Ajgaonkar, CTO of Intelligent Edge, and Ken Seier, the National Practice Lead for Data and AI. Thank you both for being here.
Thank you for having us.
Thanks, Ben.
As we know, computer vision is a technology that's been gaining ground recently as businesses continue to explore innovative applications for AI. In this three-part series, we'll be taking a look at some specific industry use cases along with some practical and technical considerations for those who might be interested in how this technology can give their businesses an edge. But for today, let's get started with some of the big questions. First off, for those who may not be familiar with the technology, what is computer vision? Ken, how do we define it?
Sure. Computer vision is a form of artificial intelligence. And while that's a fairly misunderstood and fancy word, artificial intelligence is just using math to understand patterns in historical data and to apply it to the present and the future. So in this case, we're talking about using that math to understand what might be in an image or a set of video. What we do to build a computer vision model is we take a number of images or a section of video, we annotate it to understand what we're trying to identify or recognize or find. We use that math to create or to understand the patterns in that video and to predict in future video or imagery whether or not that pattern is recurring. So we might be predicting, say, whether or not a intersection is busy or a light is red for a self-driving car. We might be predicting whether a part on an assembly line is good or maybe it doesn't meet standards, or we might be trying to predict whether or not a certain zone is safe for a human to operate in. In all those cases, we're analyzing historical video, training a model, and then using that model to predict an outcome or a classification in present and future images.
Thanks, Ken. A lot of people may be familiar with computer vision in the form of self-driving cars, which rely on hundreds of thousands of computer vision models to identify traffic signs, cars, and pedestrians. But not all computer vision applications are that complex. So once we've created a model, how do we implement it? Amol, what devices and technologies are involved in a computer vision system?
So, like you said, not all computer vision solutions are complex, right? Once you have the model, the idea being that you have to run the model you could run the model in the cloud, or you could run the model at the edge. So when I say edge, it's just another compute device that's closer to where the input is being generated. So wherever your video camera is or your other surveillance systems are, we bring the compute right there. And how do we run the model in that edge device so that you get reduced latency, you get inferences quickly? But the other part of operationalizing these models is to be able to update these models remotely as well. So imagine you've deployed this in 10 different locations. You've updated your model now with a new data set. And now you want to update this model in all those 10 locations. How do you do that, right? So using the cloud and the hyperscalers and putting your device management solution there and having your models run at the edge, you are then able to update those models and put a complete ML ops pipeline in place so that when you collect new data, you train the model, you have a new version, you want to test the model again and maybe test it in select locations, you are able to then deploy it back onto the edge, test it, look at the inferences, decide which one is better, and then make the switch for all the locations. So operationalizing an AI solution or a computer vision model is critical to the success of the entire solution itself.
In the past few years, we've seen more and more use cases for computer vision coming from different industries. We'll get into some more specific examples in part 2 of this series, but on a high level, why are organizations investing in computer vision these days? Are there common threads in terms of benefits or business outcomes? Why don't we start with you, Ken?
Sure. Computer vision is a really powerful and flexible tool and can be applied to a wide variety of use cases. And computers are really good at executing the same task over and over again, whereas human operators can experience attention or cognitive or decision fatigue. This gives us an opportunity to apply that consistency to human decisioning processes to enhance human operation or human safety. And in some cases where we can fully automate the responsibility to a computer vision model, it frees human workers to focus on more complicated and valuable tasks that AI can't approach. We're seeing computer vision across industries providing incremental improvements to safety, to quality, to top and bottom line, operations, logistics. And those small incremental benefits, sometimes 1% benefits, they really add up over time, leading companies to need to operationalize more AI.
Speaking of operationalization, Amol, can you touch on that piece of the computing on the edge?
Absolutely. So once you've identified the use case, right, Ken said, and you've built the model for it, operationalizing that at the edge does a couple of things. One is it reduces your latency, so your response time of sending the image frame to the cloud or somewhere else like a data center, analyzing it, getting the inferences back in a meaningful manner, so that the people on the floor, right, at that place can actually take action on it. That's the end goal. So bringing the model execution at the edge reduces that latency. Second is it also reduces the costs in terms of storage. So if and video is notorious for that, right? So if you want to send a lot of video data to the cloud, first of all, there's latency. It's going to take up some bandwidth, so you're going to pay for the bandwidth plus the storage cost. So you could reduce that by actually having storage on-prem near the edge itself, have a lesser impact on your network bandwidth, so that you're not hogging the bandwidth for just uploading the video. It's happening in the local loop on a local network, so it's quicker. And when you put all of these together, along with the 1% increase or decrease, as Ken mentioned, holistically, it really accelerates the value of that solution, right? So you're looking at the business aspects of it, you're looking at the outcomes, and then you're saying, okay, well, if I operationalize it this way, I'm going to get more savings, right? So you're accelerating or you're increasing the value of your solution by making sure that you've saved every bit of money executing that model, and making sure that you get the results as quick as possible.
Any emerging technology is bound to come with some general misconceptions. In your experience, what are some things business leaders or employees may not fully understand about computer vision? Are there any common questions or concerns you've encountered? Amol, let's start with you.
Sure. I think the misconception about the computer vision models is I feel that the people think it's magic, right? It'll just happen, but it's literally, and Ken has mentioned that to me so many different times in so many different ways, is garbage in, garbage out. So the training or the collection of that training data is extremely useful, and that does require time. So even though there are models in the market, and you could obviously start with them, but making it yours, making it very particular, and so that it works for your use case with your lighting conditions to gather the right data, it becomes super important, so that we can train the model and then be able to deploy that model, right? So testing and managing of the models at scale is also another misconception, where people think it's one and done. You build a model, you deploy it, and we're all set. I think it's a lot more than that to make it viable solution, especially the managing the models at scale. So once you have multiple versions of those models, how do you manage those? How do you know which model is the right one? Which version is deployed in which location, at which edge, for what use case? And being able to do that at scale is extremely important. So if customers think of a computer vision solution or any edge solution holistically, all of these will come together.
And Ken, are there common questions or concerns that you've encountered?
Sure. So modern AI is a very narrow version of intelligence. It's not the broad thinking intelligence that we see, say, in science fiction. And computers learn to identify and classify objects very differently from humans. They can be very good at it, They can be very consistent at it, but they can't go outside the bounds of what they've been taught to recognize. And that means they make very different and interesting kinds of mistakes where a human wouldn't. As Amol has been talking about, it's very important to gather the correct type of data. It's very important to assemble that data into a properly weighted training set and to train the model using a complete range of experiences that it would have in operation. That's very easy to do in, say, a plant or assembly line where that environment is very controlled. It can be more challenging in computer vision. And there's a great case about an early example of a self-driving car under human operation. It was just being tested. It went by a car carrier, one of those big trucks with 9 or 10 cars on the back, and it completely lost its mind. It could not figure out how 10 cars were all stacked up on each other. And that's the kind of importance that we have to put on that training set. But it goes so far beyond that. Like Amal's been talking about, that having that mature productionalization, being able to retrain a model, to understand when that model's falling out of tune, and then all the way into the human and business processes, because you want to make sure that whatever you implement for artificial intelligence, that it's responsible and that you're following principles of responsible AI.
Ken, you just mentioned responsible AI. Can you talk a little bit more about how it relates to computer vision?
Absolutely. We've been talking about the impact of AI in terms of business context, top and bottom line benefits, operational efficiencies. These are all very important. But at the same time, we have to understand that these types of 1% improvements also affect human lives. We always need to be thinking about the humans who are going to be impacted by AI, both positively and negatively. We're talking about using AI in work environments. We talk about using AI in healthcare. We talk about using it in security and safety. We need to make sure that whatever we implement is going to have an impact across the entire population that we're serving and that we're not serving that is positive. It's a very powerful tool. It moves very quickly. It's very automated as it reaches maturity. And so we need to be thinking about the security of our AI and the underlying data. We need to think about bias and inclusion in our data set and how this will impact different populations. We need to be thinking about how we intend our AI model to be used, and then how it could be used differently that might be unfair or biased. We need to talk about the risk of a false positive or a false negative. And we need to make sure that whenever a impactful human decision is being made, that there's an opportunity to bring a human into the loop, a human override, that if the AI model makes a mistake, if it's inaccurate, if it was fed bad data, or maybe it wasn't trained properly for this particular case, that a human being has the responsibility and the awareness to come into the decision-making process and make a better decision for the humans being impacted. AI is so powerful. We have to make sure that we always remember that AI is in service of people.
So our last question for today, and Ken, we'll start with you. As we start to look ahead, what excites you the most about computer vision, and what role do you see it playing in modern businesses over the next 1 to 3 years?
So artificial intelligence, and especially computer vision, because it's so flexible, it has the power to drive so many changes, better quality, lower cost goods and services, really dynamically reshape and disrupt markets. It only takes 1% improvement for a company to disrupt its marketplace. We want to be working with these companies in order to capture the best intelligence of their SMEs and augment and enhance their entire workforce using those SMEs and artificial intelligence. We want to be making sure that we're pointed at improving quality of life, the health, the safety, the well-being of humans, both for these companies and that consume from these companies. And we really want to be making sure that we're doing that in an iterative, responsible way so the companies can continue to build more and more responsible AI to drive that value.
Amol?
And I think from my perspective, as Ken mentioned, as we build more of these solutions, bringing them down to the edge so that people see or customers see the most value, get the most value out of those solutions, and be able to respond using the inferences, make better decisions. And they use their valuable time, right? The human workforce uses their valuable time to do more valuable tasks, right? Where their talent and the skill is most used, versus making the same decisions over and over again by just looking and deciding whether it's right or wrong from a product point of view. I think intelligent edge is the new cloud, and bringing those workloads back to that edge to do the really time-sensitive processing, and then using cloud for scale is going to be super important. I think that's really exciting for me.
Well, thank you both for sharing your thoughts with us today. In the next episode in this series, we'll be taking a deeper dive into some of the unique ways computer vision is being applied across different industries to improve experiences and processes. I look forward to talking with you both again next week.
Thank you, Ben.
Thanks, Ben.